All right, in this section, we're going to take those special parallelograms, the rhombus and the rectangle, and we're going to now see how we can prove a quadrilateral is a rhombus or a rectangle. And you're going to notice, I'm going to tell you right off the bat, um, for all of these theorems and properties, conditions today, we need to know we have a parallelogram first. So if we don't know it's a parallelogram, we don't know it's a rhombus or a rectangle based on these conditions. Okay? So our first condition for a rhombus says that if we have a pair of consecutive sides of a parallelogram that are congruent, then the parallelogram is a rhombus. So I want to highlight again, notice how it's talking about a parallelogram, not a quadrilateral. So that is kind of an embedded condition. Okay, so we want to know we've got a parallelogram first, and then its consecutive sides need to be congruent, all right, for this to be a rhombus. So let's take a look at this diagram down here. We've got this quadrilateral ABCD, and we need to know a couple of things about this ABCD before we can conclude it's a rhombus. So first off, we need to know ABCD is a parallelogram. All right, that's ABCD. Um, so we need to know ABCD is a parallelogram. Then secondly, this condition, this theorem says, well, if one pair of consecutive sides are congruent, then the parallelogram is a rhombus. When we talk about consecutive sides, it's like the same idea as consecutive angles, so one after the other. So for example, if I tell you AB is the side we're looking at, then its consecutive side could be either BC or AD. So if I tell you AB and BC are congruent, then that, in addition to the fact that ABCD is a parallelogram, tells us that ABCD is a rhombus. Okay? So our second condition now looks at angles. So specifically, we're looking at things that were kind of specific to a rhombus. So here we're looking at if one diagonal of a parallelogram bisects a pair of opposite angles, then we know we have a rhombus. So if you look at that ABCD and let's say I have this diagonal AC, first off, remember we need to know we've got a parallelogram. So once again, you see this is all talking about parallelograms. If you don't know if it's a parallelogram first, start with that. Prove it using one of our 6 reasons. Now once we know we have a parallelogram, we can apply one of these. Okay, so what this is saying is if I know this diagonal, for example, AC, bisects its opposite angles, meaning angle A, oops, not A, my bad, angle BAC is congruent to angle DAB, which are these two angles right over here, then I have one pair of congruent halves, so I have the angle BAD being bisected. Now, we want to know that the other side is also being bisected. So we would also want to know that angle BCA is congruent to angle DCA. Okay? So we need to know that both of those angles are being cut in half. So right over here. And of course, if this is a parallelogram, actually, these bisected halves should be the same because our opposite angles are congruent. But just quick note there. But anyway, if I know the two angles here at the ends of my diagonal are being cut in half, then that plus the fact ABCD is a parallelogram tells me we have a rhombus. All right, so then our last condition for a rhombus again starts off with the first condition being we need to have a parallelogram. But this one goes back to, again, what was unique to just a rhombus, and that was when your diagonals are perpendicular. So in a parallelogram, if our diagonals are perpendicular, we have a rhombus. Okay, so once again, you'll see that common factor they all have here. We have to have a parallelogram first. So once again, if you don't know it's a parallelogram, then we can't conclude it's a rhombus using this theorem. So if I know ABC is a parallelogram, and then I know that the two diagonals AC and BD are perpendicular, then I can say it's a rhombus. Remember, how do I know if it's perpendicular? I should be able to see what kind of angle is in there. Remember, those should be some 90-degree angles, right? Oops. So each of these angles would be 90 degrees. So you'd be able to see that or determine it somehow. right? So we know that AC is perpendicular to BD, and then that tells me ABCD is a rhombus. All right, so let's take a look at this diagram right here. For example, this should actually say example 1. I don't know why that's a 3. So example 1, we want to determine if our conclusion is valid, and if not, tell what additional information we need. And we're going to use this quadrilateral EFGH for both A and B here. So if you take a look at A, I know that EF is congruent to FG. Awesome. I know that EG is perpendicular to FH. All right, so I've got diagonals that are perpendicular. So I want to say this is a rhombus. And you might be thinking, yeah, that is a rhombus because I've got perpendicular diagonals and I've got a pair of consecutive sides that are congruent. So this is looking really great. But remember, what did we highlight in every single one of our conditions? This shape needs to be what shape first? It needs to be a parallelogram. Can I say this is a parallelogram? Hopefully, you're seeing no. So this is not valid because EFGH needs to be a parallelogram. So I've erased some of my marks so we can do part B. And actually, if you look at part B, we want to prove this is a square. So before we can prove it's a square or check if it's a square, let's talk about rectangles first. We're going to talk about our conditions for rectangles, and then we'll come back and do part B. So let's go ahead and skip forward. All right, so we've got two conditions for this rectangle, but this rectangle is going to be very similar to our rhombus in that we need to show that we've got a parallelogram first. So what's our first condition? Okay, so you again notice I've highlighted parallelogram because we need to know it's a parallelogram first. So if I know ABCD is a parallelogram, and in addition to that, if I know just one angle is a right angle, for example, if I know angle D is a right angle, then I can say ABCD is a rectangle. Because remember, by definition, a rectangle will have 4 right angles. So if I know this is 90, and because it's a parallelogram, all our same side interior angles are supplementary, that'll give me 90, 90, 90, 90, 90, and 90, right? So that's our first condition. What's our second condition? All right, so once again, highlighted here, our figure needs to be a parallelogram first. And if the diagonals are congruent, then we know we have a rectangle. So again, these conditions for rectangles and rhombuses deal with the things that are specific or unique to just your rectangles and rhombuses. So if I know ABCD is a parallelogram, that's check 1, and I know the diagonals are congruent, that means AC is congruent to BD, then ABCD has to be a rectangle. Okay? So now we know our conditions for rectangles and rhombuses. I want to give you one note though. So if I want to prove something is a square, remember a square, the conditions for a square are it has to be a parallelogram, rhombus, and rectangle. So you'd have to show all 3 things. So we need to know, for example, the diagonals bisect each other, and one pair of consecutive sides are congruent, and the diagonals are congruent, right? So you need to have 3 things to show it's a square. So let's back up to part B of example 1. Okay, so let's check and see, is this a square? So why don't you ask yourself first, is this a parallelogram? Why don't we check that first? So what did you think? Is it a parallelogram? Well, if you look at the first couple of givens, we know EB is congruent to BG and FB is congruent to BH. So since your diagonals bisect each other, oops, that says each over there, we've got a parallelogram. That checks. So we need to check if it's a parallelogram, rhombus, and a square. Now let's check and see, what do you think? Is it a rhombus? Well, hopefully you saw these two triangles are congruent. So if EBF, which is right here, and I'll highlight that in green. So if EBF is congruent to EBH, then I could say something about EF and EH. What do you think that would be? Well, that would mean these two sides are congruent by CP/CTC. So we would be able to say EF is congruent to EH by CP/CTC. So that means if EF is congruent to EH, I have a pair of consecutive sides that are congruent, so that means it's a rhombus. Check. So finally, ask yourself, is this a rectangle? So what do we think? Take a look at the last piece of information. I'm going to go ahead and just erase all this because I've marked that all up for the other two. Since we already know it's a parallelogram and a rhombus, I don't need those marks anymore. And now let's check and see that last piece. So it says EG is congruent to FH. And if you look at EG and FH, these are diagonals. So I have congruent diagonals. Remember, congruent diagonals tells me I have what shape? Well, it tells me I have a rectangle. So 1, 2, 3, check, check, check. Yes, I can say EFGH is a square. So yes, it is valid. So the conclusion is valid. There you go. Okay, let's do one final example that's related to this where we're looking at a square. Remember to come back to class with questions if you have any. Okay, finally, this should have said example 2. I don't know what I was thinking when I was numbering these. Okay, example 2, let's use diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all names that apply. So remember, read the directions. These directions are telling you some neat things. Number 1, it's a parallelogram, so don't even worry about proving it's a parallelogram. This checks off our condition we needed to know, right? It's a parallelogram. Awesome. Now we're just checking to see if it's a square, or sorry, if it's a rhombus, if it's a rectangle, or if it's both, which makes it a square. Okay? We want to list everything that it is. So let's go ahead and plot our points. All right, and hopefully your diagram isn't as wobbly as mine, but you get the idea. Remember, don't assume anything. So you might say, okay, that looks like a rectangle, let's move on. But don't assume anything, right? So what we need to do is we need to show with algebra work, with some geometry, that we have a rectangle, a rhombus, or both. So notice in the directions, I've also given you another hint. We're going to use diagonals here. Um, so I want you to use diagonals. So what do I do to use diagonals? Remember, to use diagonals to show we have a rhombus, our diagonals need to do one of two things. They need to bisect a pair of opposite angles, but that's really hard to do on the coordinate plane. So let's not do that, and let's say the diagonals are perpendicular. Because I know perpendicular means opposite reciprocal slopes. So what I can do is I can go ahead and sketch in these diagonals, and then I can count rise over run, or you can go ahead and just do slope formula for EG and EH. Or excuse me, oh, I wrote two of the same letters. That should be F. So EG and FH. Let's make that clearer. That should be F. There you go. Okay, but again, like I said before in class, I like doing rise and run. So if you do this in your work, I somehow need to see it. So it helps to be, you know, up 1 and then over 1, 2, 3, 4, 5, 6, 7 plus 7 to just show how you counted it on your coordinate plane. So that's positive 7. Okay, so here slope of EG is equal to positive 1 over 7. Then I want to find the slope of FH. And again, you can draw on that diagonal. And I can again count my rise and run. Oops. All right. So I'm going to go down 1, 2, 3, 4, 5. So that's minus 5. And here I'm going to go over 1, 2, 3, 4, 5. That's a positive 5. So that's going to be rise over run. Oops. All right, super messy today. So rise is negative 5 over run, which is positive 5, so that's equal to negative 1. So it's not a rhombus because I don't have perpendicular slopes. Okay, if I ended up with negative 7, that would have been great. That would have been a rhombus. But here, they're not opposite reciprocals, so no, not a rhombus. So now let's check for a rectangle. Now, what do I know about diagonals of a rectangle? Well, the diagonals should be congruent, right? How to know if they're congruent? We need to use that distance formula. So don't forget your distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then you want to go ahead and do that work. So there's all that work. Don't forget to simplify if you can. So I know even though you're just checking to see if they're the same number, I want you to make sure you simplify it completely. So since we can say that EG is congruent to FH, that means the diagonals are congruent. So EFGH is a rectangle. Since we already know it's not a rhombus, it can't be a square because it has to be a rhombus and a rectangle to be a square. And that is it. Please come back to class with questions.